Hi, beautiful people. Okay, so today we're talking about how can you find area and perimeter in the coordinate plane. But before we do that, we really want to talk about what is a polygon, how do you classify a polygon, and then we'll talk about doing that. So the first thing we want to do is define the word polygon. Okay, polygon comes from the two words poly, which means multiple, and gon, which means sides. So a polygon is a connected figure with multiple sides. Now, I know you probably think this word connected is probably unnecessary, but it's really important to note that a polygon is a connected shape. So it has an inside and an outside, and they're very clearly defined. So I'm going to draw an example. Okay, this is my not super well drawn example of a pentagon. Pentagon. Okay, we're going to label a few pieces of this polygon. So the first thing is the side. Okay, and the side is obviously the length between two vertexes. Okay, and then the second thing we're going to call is the vertex. And a vertex is basically where two line segments meet up. So a pentagon has 5 vertexes and 5 sides because it's a 5-sided shape. Penta means 5. Okay, and sides are named just the same way that segments are named. So if this vertex was called A and this vertex was called B, this would be side AB. Okay. Or side BA, if you want to name it that way. You can do it either direction. Doesn't matter because the direction of a line segment doesn't really matter. Okay. All right. So the next thing we need to know in order to classify polygons is convex versus concave. So convex means that basically all the vertexes are exterior to this shape. So, for example, basically most of the shapes that we know how to draw. You could draw a square. It's also convex. You could draw like a trapezoid sort of thing. It's convex. Okay, concave is when you have something that's got like maybe a point out and then it comes back. Okay, and it's concave because if you notice right here, there's a bunch of zero space in between these two vertexes. This zero space forms kind of like a cave. That's how I associate it, concave. And it makes it so that it's a concave shape versus a convex shape. So it has to do with whether or not you have a corner or a vertex that is inside the shape. Okay. The convex shapes have all vertexes outside the shape. Concave one has at least one that's inside. Okay. So I'm going to draw some examples over here. Okay. The one on the left is obviously a concave shape because, again, it's got all this empty space right here, which means this vertex is interior. So this is concave. The shape on the right has vertexes all around the outside. There's no empty space. So this is convex. Convex and concave. Okay, and then the last thing we're going to do is we're going to start a table about all of the different shapes and what their names are. So I'm going to start it on a new page. Okay, so my table basically just has number of sides and shape name. So when it comes to polygons, we have to start with three sides. Because if you just have a two-sided shape, then it is a non-connected shape. There's no way to connect those two sides. So this is no longer a polygon, it's just an angle. Okay, so you need 3 sides. And the shape that has 3 sides is called a triangle. Which you know. Again, a triangle, the word tri comes from the word 3, like tricycle, triathlon, etc. Tri comes from the word 3. Okay, so then we're going to go on to the next ones. Okay, so take a second, pause this, write down those numbers on the left, and then try and fill out the names that you remember. And then pause it, and I'll go over the names. Okay, so these are the answers. Quadrilateral, pentagon, hexagon. For 7-sided, you can call it a heptagon or a septagon. Heptagon is the preferred term. Octagon, nonagon, decagon, engon. Okay, I'll talk about that in a second.